This is Quick Clip 2.12, States of Matter. And when we discuss the three basic states of matter, solid, liquid, and gas, we often talk about three of its characteristics: shape, the motion of the atoms, as well as volume. When we're considering shape, the shape of a solid is always the same. No matter where you put that solid, its shape is not going to change. So we say that it has a fixed shape or a definite shape. Liquids, however, will change shape. If you pour it into a glass, it takes the shape of the glass, no matter what that glass is shaped like. Same thing for a gas. If you put a gas into a round balloon, it'll be round. If you put it into an oval balloon, it will be oval. For the motion of the particles, the atoms or the molecules, the solids will vibrate, and they have some motion. They have the least amount of energy, so they will vibrate even though they are tightly packed with one another. For a liquid, the molecules and atoms are also tightly packed, but they have more freedom of movement, and they can flow and be fluid. They can move past one another. As far as a gas goes, the molecules and particles have the greatest amount of energy and move with complete freedom. For volume of a solid, much like a shape is fixed and definite, the volume is also fixed and definite. So it's not going to grow and shrink without undue force, without an outside force. For a liquid, the volume also is fixed and does not change. Even though the shape of it will change, the amount of space that it takes up, the volume will not change. And then for a gas, this is different. The volume of a gas will change. So the bigger the container, the gas will fill that container. The smaller the container, the gas will fill that container. So the amount of space a gas takes will be different. To further illustrate that, we're going to go to a simulation to show how this works. So for this simulation, if you look in the upper right hand corner, you can see that these small little blue spheres represent neon, and right now it's in the state of a solid, and the atoms are vibrating, has very little motion, and they are in a fixed position, and the shape remains the same. If I heat it up, then the bonds will break, and we end up melting it down to a liquid. And now the atoms are more free-flowing, they're moving a little bit more, and it takes the shape of the bottom of that container. And then finally, if I click gas, then the atoms have the greatest amount of freedom, and it's going to take the shape of the full container and fill the container. So its volume will change. So again, looking at the solid, it is vibrating, its shape remains the same, and its volume remains the same. Here, the liquid, it's moving more freely. The shape will change depending on what container it's in, but its volume will stay the same. It's not growing and taking up more space. However, for a gas, it has the greatest amount of freedom. It's moving the most rapidly, and then its shape will change, but also its volume will change. So if this container were bigger, the gas would expand and fill that entire container. I wanted to point out a couple more things. Here we have oxygen as a solid, and I mentioned in a previous video that oxygen is a diatomic molecule. They travel around in pairs, and you can see that in the picture there, that they are molecules of two oxygens. And then here, this is water, and if you take a good look at the molecule there, you can see that they have two hydrogens attached to an oxygen, that they are vibrating as a solid, and then when we melt that down, it breaks down to a liquid, and then it turns into a gas, and it has all the freedom of a gas. Also, keep in mind that none of these molecules changed. None of the atoms changed, none of the molecules changed. The only thing that changed was the arrangement. So this is an example of a physical change, not a chemical change. Nothing new has been created. So as a solid, that's H2O as a solid, but it's H2O. As a liquid, that's H2O as a liquid, but it's still H2O. And then finally, This is still H2O, but it is in the form of a gas.